Michelle fight for that white gold. This one for them hood girls.
$8,000 are assigned to a manager for the production and promotion of a new product. It is estimated that if X thousand dollars are spent on production and Y $1,000 on promotion, there will be F of X comma Y equals 50 square root of X Y to the 3/2 units of production. How much money should be assigned to production and how much to promotion to maximize sales? B. Suppose $1,000 more are assigned to promotion and production. Apply the Lagrange multiplier to estimate the change in the maximum level of sales.
We will start with the first question. We know that X equals money for development and Y equals money for promotion, and that our formula is F of X comma Y equals 50 square root of X Y to the 3/2. This represents the sales. The first step is to partially derive functions so we can find the maximums. We will start with fx. Fx is divided by 2 and that leaves x to the minus 1/2 and y stays the same. Now derive fy. Fy equals 50 times 3/2. X stays the same and y is left to the 1/2 power. So fy equals 75x to the half times y to the half. We know that our budgetary constraint is x plus y equals 8 because we have $8,000 to spend. We find gx and gy based on that. Their derivatives are both 1, and since x derives as 1, then y is a constant and therefore equals 0. But from this we know that gx is equal to gy, and therefore fy is also equal to fx. We remember our partially derived functions from the first step. Since we have stated that these equations are equal, now we match the functions. We will place all of the y's on one side and then send the x's to the other side. This leaves us with y to the 3/2 divided by y to the half. On the other side, 75 is divided by 25, and x to the half is divided by x to the minus half. Because we are working with exponents, they can be subtracted. So 3/2 minus a half, and on the other side 3, and the exponents of x, a half minus a negative half. After you do all the subtractions, this leaves you with y equal to 3x. Then you must substitute y into the budgetary constraint function, which is x plus y equals 8. And this way you find x, which is equal to 2. So now we substitute x equals 2 into the budgetary function and find y, which is equal to 6. Now that we know that x equals 2 and y equals 6, we can substitute them in the original function, which tells us the maximum sales we will achieve with $8,000, which in this case is 1,039.23. Now, let's remember the second problem. We are given $1,000 more to spend, so our budgetary constraint is x plus y equals 9. We will apply the Lagrange multiplier to estimate how this changes the maximum in sales. We will use the partially divide functions from the last problem. However, we only need one, and you can choose whichever one you want. We will also use x and y's previous values, which were 2 and 6. We will substitute these in our chosen equation, and the result is the extra sales that are produced thanks to the added $1,000. Now, all we have to do is add up 1,039.23 with 259.808. This is equal to 1,299.04, which is the maximum sales with $9,000.